All right, so we're going to start 2.2, and that's just problem solving with rational numbers in decimal form. We're going to be checking out a bunch of the stuff that you need to do on your Part A no calculator test for the PAT, as well as being able to use a calculator and just understanding what the question is actually asking. So the first thing that it asks you to do is to be able to add and subtract rational numbers in decimal form. It seems that like when people are working with decimals, they get stressed about it. So we just need to practice and we need to just remember some of the pieces that are important. I'm actually going to flip over here and do just a little bit of looking at how we would just succinctly add something like 2.81 plus 3.361. So if you were asked to add decimals, you need to remember that all of the columns need to line up. And that's really just basically such an important piece of doing math. So if I'm going to add this, I'm going to stack them. And so I'd put 2.81 and I'd put my add sign here. Now, there's a decimal in this one here. It's going to go here and I'm going to fill in the blanks around it. 3 was on this side, 3 was on this side, 6 is here, and 1 is here. There's an empty space up here now, and because there's an empty space up here, we're just going to throw in the 0 to fill it in. And then we can, because now that everything is nicely lined up, we can just go ahead and add 0 plus 1 is 1, 6 plus 1 is 7, 8 plus 3 is 11, put the decimal down, we've got 5 and 6. So this is our answer right here. So that's simple enough. However, if we go back and we take a look at the problem that they're being asked, that is not that. Sorry. Oh no. Okay, there. All right, sorry. So this is the question that we're being asked is 2.65 plus, and then in brackets, negative 3.1. So actually what's happening here is there's a plus and a minus right beside each other. And so I'm just going to write this over here and take a look at that one more time. So 2.65 plus, and then there's a bracket, minus 3.81. So there's a few things going on here. You can't have two signs beside each other. It just doesn't work. So this scenario here means that some math is actually already happening. And whenever you have these brackets, and in grade 9, and we talked about this in grade 8, but whenever you see brackets like this, it means that we're multiplying. So for instance, if I have 2 bracket 3, that means 2 times 3, and so that would be 6. So in this case here, where you have these brackets, it's asking you for a multiplication. And the things that you're multiplying are actually these two signs right here, because they're the things kissing. That's what I call multiplying. You'll notice here the two numbers are kissing, but here the two signs are kissing. So that's why I have down here a positive times a negative. So guys, we need to remember our rules. Whenever we go a positive times a negative number, it's always going to be a negative. Whenever we have a positive times a positive number, we're always going to get a positive. And whenever we have a negative times a negative, we're always going to get a positive. So it is super important to remember these rules. And in this case, we have a positive and a negative touching. And so we look to our first step here. We know that the answer is going to be negative. So if we were to put this into our calculator, and you can try that right now, write 2.65 plus, and then use the brackets, bracket negative 3.81 and a bracket, and push equals, you will get your answer of negative 1.16. Make sure that you write it exactly as the math question asks you to. So you can just literally put that in to your calculator to do that. So now we're going to actually go back to Notability and see if we can solve this problem on our own, and I'm going to use a different number. So if we had same scenario, let's do 6.5 plus negative 4.61. I want to take a look at this from a perspective of doing this without a calculator. What if you have to do this without a calculator? So the first thing that I want you to look at is which number is bigger. Is it the positive number or is it the negative number? Which one's bigger? So I can tell right away that -4, well, it's not bigger, but which one has more? -4.61, that one does. So what I always do is this, is I always take, I'm just looking at the front numbers. So I'm looking at 2 and 4, and I notice that 4 is bigger. It's on the negative side. So guys, actually doing this, 2.65 plus minus 4.61. Like, how do you do that math? That just doesn't line up, right? Because there's a minus here, and so it's a plus minus, and it's like, I don't know how to line this up. So I don't do that. I actually just look at these front numbers, and I put the one that has the biggest front number on the top. So that's this one right here, 4.61. So I'm just going to put it on the top. Then I put another number on the bottom and line everything up, so 2.65. So now, because there's a minus in the question, everyone see this minus? We know that when there's a plus and a minus, the minus always wins. So I'm just going to put a minus, I'm just going to put a minus, that's minus right here because we're subtracting this. The answer is going to be negative. And I just want you to see this just from looking here. Look at this, 2.65 versus -4.61. If you were to shove this number into this number, you know that this guy would lose. He would get eaten by the negatives because there's more negatives, right? So that's why I'm putting it on the top. And so this is part of my thought process. It's easiest, and for no calculator stuff, it works really well. So this number is eventually not going to exist anymore, and the answer just has to be negative. So that's why I'm putting this number on the top and I'm doing a subtraction. Then I need to subtract. Guys, subtracting is hard, okay? Remembering how to do it, we're going to practice it in class. If you're online with me right now, this is something that we need to practice. 1 minus 5, you can't do it. So you have to make it into an 11. That means you have to borrow and take this guy down to 5. Okay, and so then you do what you've just solved, like what you've just looked at right now. You can do 11 minus 5. That is 6. So you do that part next. Then you look at this 5. Can 5 subtract 6? Well, dang it, it can't. So then you give it 10 and you make it into 15. But since you made it into a tenner, you got to borrow over here and you got to put a 3 here. So then you do this guy right here. You do the math. Just do it right now. 15 minus 6. So 7, 8, 9, 10, 11, 12, 13, 14, 15 is 9. So, so then we're going to put a 9 right there. Bam. Decimals come same spot. 3 minus 2, praise the Lord, that's 1. Bam. You get your answer, and your answer is always going to be negative. Now, I know this doesn't make sense at the very top here, but what I'm doing, guys, is I'm just making this problem into a situation where I'm able to subtract and then place the negative. But you have to ask the question first, which one was bigger? And remember, guys, look at this one was more negative. -4 was bigger than 2. So this -4 eats the 2, and the answer, no matter what, is going to be negative. So you do the subtraction straight through, and then you add the negative at the end. I know it's a lot to remember, but let's just do one more. Let's go 10.3 plus minus 15.6. All right, so here's the situation, you guys. Whoa. Here's the situation. So I want to make sure that turns into the right thing. So I'm going to go ahead and I'm going to put the bigger number on the top. So what's the bigger number? Well, we know that it's 15 because 15 versus 10. Okay, so 15 is going to go on the top. Okay, it's negative. So the answer is going to be negative. I have to remember that. Okay, plus and minus, so the subtraction wins. It's the subtractions right here. It tells you to do that. 10.3. Just go ahead and do a straight subtraction. 6 minus 3 is 3, goodness. 5 minus 0 is 5, and 1 minus 1 is nothing. And remember that the answer is negative, and bam, there you go. This is how you work with decimals when you are subtracting, and it seems really hard, okay? So you've got that. All right, so obviously, guys, you can go ahead and punch these types of equations into your calculator right now, right here and right here. And I want you, whenever you're putting them into your calculator, to do it exactly as it's written to get the answers. Okay, so just making sure that you do that. People always ask me all the time, dudes, look, if I'm adding and subtracting, and if I have, like, say, -1.6 plus negative 4.8. Is it always going to be negative? Is it always going to be positive? And I have people asking all the time. But we're going to start just working with these numbers and recognize that there's only a few times where stuff is always going to be negative or always going to be positive. It's not the same as multiplication. So when you're adding and subtracting things, you've got to do the versus strategy like we did on the other page and just understand it. So I'm not going to throw those into my calculator, but you can, and you can trust that you're doing it correctly. Okay, so multiplying and dividing rational numbers also follows a form. And so we need to make sure that we remember these rules. Basically, it's a law. It's always the same, and it will be the same all through math. And so you have to memorize these things. You have to know that when a negative times a positive happen, that you always get a negative. You always have to remember that when a negative times a negative, there's two negatives together, you get a positive. And when a positive times a positive, you always get a positive. Now, these rules are essential to know, and it really has to do with how many negatives are actually appearing in the problem for you to realize, like, if the question is going to be have an answer that's negative or have an answer that's positive. So if you look at this one right here, you'll notice that there's only one negative in the problem. And so whenever there's an odd amount of negatives, you're always going to get a negative answer. So I want to just give you an example. If we had -3 times -2 times -1, since there are 1, 2, 3 negatives, the answer is going to be negative. So it just has to do with how many odd negative numbers there are and how many, and then you can always figure it out. So in this case, if we're looking at here, whenever there's an even amount of negative numbers, then the answer is always going to be positive. So I just want you to see there's 1, 2 negatives in this problem. So if we went -2 times -2 times -2 times -2, since there are 1, 2, 3, 4 negative numbers in this problem, then this answer is going to be positive. That's what I just need you to know. Obviously, when it comes to being positive all the time, there's nothing that changes, but it just has to do whether there's an odd number of negatives in the question or an even number to determine whether your answer is negative or positive. So if we scroll down to this example right here, we see 0.45 times -1.2. If we did that times -1.2, we get -0.54, and that's because there is one negative in the question, and so that's why the answer is negative. So there's an odd number of negatives, and so that's why the answer is negative. In this case, before I even start, I'm going to look and see, okay, there's a negative number here, and there's a negative number here. So there's 1, 2 negatives. So looking back up here and looking at our rules, whenever there's 2 negatives or an even amount of negatives in the question, the answer is going to be a positive number. You throw that in your calculator, 0.68 times -7.9 times -1.3, and you get 6.9836, and the number is positive because there are 2 negatives. So super important to know. We'll talk about doing this multiplication of decimals and stuff like that without a calculator in a little bit. So there's some more problems that you have to do. Here's some more problems. Now, I just wanted to kind of go over these questions right here without a calculator. So first of all, obviously what we've been looking at, we look at this question, we see that there's one negative in the question. We're multiplying, so we know the rule. So we know that the answer is going to be a negative number. But how do I do 3.5 times negative 1.2 without a calculator? Okay, and so I'm just going to kind of roll over here and open something new here if I can get to it. And I'm just going to show you how to multiply numbers. And oh boy, sorry. So here's a new page here. I'm just going to show you how to multiply 2-digit numbers. So if I had 38 and 42, and I wanted to multiply those together. Here's the deal. Like, there is the old way of multiplying, which is the way that I learned when I was growing up, and it looks like this. You definitely don't have to follow this if you don't understand it. This is not the way that I recommend to use, but I'm going to show you what I learned when I was a kid. The first thing you look at is you use the 2, so you go 8 times 2, which is 16. You put the 1 on top. You go 2 times 3, which is 6, plus 1 is 7. You put the x through the first number. You put a 0 there. 4 times 8 is 32. You put a 3 up here now. 4 times 3 is 12, 13, 14, 15. You put a 15 here. You add these numbers together. 6 plus 0 is 0. 7 plus 2 is 9. 0 plus that is 5, and then 1, and this is your answer. So that's how I did math back in the day. And for some of you, it works and you've learned it, but for a lot of you, you didn't learn how to do that. And so I don't want to force you into that. And I feel like there's a lot more errors when I see this. Something that we're looking at is called the box method, and the box method is extremely important. So what you have is a box. Okay, and the first number that we have, I'm just going to write them here, is the number 38. So in the box, we're going to use the big number first with the 0, 30, and then 8. So notice how I broke that down, 38. This one here is 42, so I'm going to put 40 in this box and 2 in that box. And now what we do is we multiply the boxes together. And so we multiply these two together. So 4 times 3 is 12. You put a 12 in the box. And since there are 2 zeros, we place 2 zeros like that. Okay, then we're going to do 40 times 8 because we're still in this box right here. So 40 times 8. Well, 4 times 8 is 32, and then we're going to put the 0 right there. Okay, and then we're going to do this box right here, 2 times 30. I'm going to go 2 times 3 first is 6. Since there's 1 0, put the 0 there. And then finally, the last step is 2 times 8, which is 16, and I'm going to do that. Now you take all of the numbers inside of the box and you add them together. So 1200, 320, 60, and 16, and add them all together. So this is a 6 here, that's 8, 9. This is 5 and 1, and check that out. We got the same answers. So the box method is something that is basically a seal the deal, get the math right. It doesn't involve as much multiplication memorization, and I really am looking for 100% when it comes to multiplying this year. So this is an important method to use. And so you could try one yourself if you wanted to. Grab a sheet of paper and you could do something like 53 times 62. If you go ahead and do that in the box method, just to practice it, the answer would be, in the end, 3,286. So see if you can get that answer doing your own box, just on a separate sheet of paper. When it comes to decimals, that's when people freak out. So it's like, really? Can I actually do 2.6 times 3.4? Is that even possible? Like, that's crazy. So whenever we're dealing in decimals, we're still going to make a box, okay? And what we're going to do is we're going to pretend for a second that the decimals don't exist, okay? And we're just going to pretend that this number is 26 times 34, and we're going to do the box method, okay? So remember that the 26 goes at the top, 26, we break them down, 34, 34, break them down. Again, do your multiplying. 3 times 2 is 6 with 2 zeros. And then we've got 3 times 6, which is 18 and a 0, right? Because there's 1 0. And then 4 times 2 is 8, and then add a 0. And then 4 times 6 is 24. Add these guys together. So you'd go 600, 180, 80, 24. You'd add those suckers together. So that's a 4, 16, 17, 18, 7, 8. Okay. Now you have this answer down here, but there's no decimals in it. So that's when we have to go back to looking at our decimals. So we need to count the positions of numbers that are behind the decimal, okay? Behind the decimal. So what do we got? We have 1 spot here, so this is 1, and we have 1 spot here, okay? 884. If I was to make 884 into a decimal, I'd put the decimal at the very end and add a 0. Now, since there was 2 spots behind the decimal, we're going to move the decimal back 2 and place it right here. So the answer to 2.6 times 3.4 is 8.84. You notice how I move the decimal over. So now it sits here. Okay, and so this is how you do multiplying decimals. It takes a little bit of practice. We're going to be doing it in our class. There will be some practice pages, but if you are wanting to do a practice on your own right now, you can go 3.7 times 4.5 and see if you get the answer. If you roll it out and I just throw it in my calculator, it should be 16.65. If you can do it in the box method, then that's awesome, and you can actually show yourself that you can multiply decimals. So that's just a side swipe there. Coming back into the notes here. These are some examples, again, that you can also do. If I throw them into my calculator, 3.5 times 1.2. Now, in this case, I know that there's a negative here, so my answer has to be negative, and so I get negative 4.2. You could do that with a box. If you did that, it would be 35 times 12, 35 times 12, and you would be able to get the answer. And then here too, since there's one negative, this answer is going to be negative, and so if I did it on my calculator for you, you would get negative 1.35, but you could also do it in a box, and just remember to look how many negatives there are to decide whether the answer is negative or positive and go for that. Bed mass. Okay, super important, and we're going to be practicing this in this unit. So obviously we have here that the B is for brackets first, then exponents, then division, multiplication. These two don't really matter, adding and subtracting. It doesn't really matter what you do first, but you have to remember that if you're going to multiply or divide, you got to do that before you add or subtract, okay? So if we have a nice little ditty here, I just wanted to point out a few things. Number one, we don't use the multiplying sign anymore in Math 9. It just doesn't exist, okay? Most of the time we don't use it because we're going to get into polynomials where we have like 3x, right? And you've done this before in grade 8, so you've seen this. We're going to use a lot of letters, and we're especially going to use the letter x, which looks like a multiplier, so we don't use it anymore. So whenever you see two numbers, what I call kissing, meaning it's the brackets are right up against it, it means multiply, okay? And so you notice here that there's this multiplying piece here and there's a multiplying piece here. If we look back up at bed mass, we notice that brackets come first. And all the time people say, well, what's in the brackets? Are there brackets? They're like, yeah, there is. Well, what's in the brackets? Well, negative 1.2. Well, negative 1.2 isn't exactly anything you can do with math. So you actually have to go to the next step. There's no exponents yet, but there is multiplication. So that comes first. And so what you would do is, and guys, you need to write it like I write it. So I'm just going to rewrite it out here. You have to do your math down the page. That's super important. And so I just want to make sure that you understand what I'm looking for when you're showing your work. I'm using my calculator this time. Sometimes you won't. 3.5 times negative 1.2 is negative 4.2. I want the answer to your bed mass right underneath that. Then you're going to drop the plus sign down. I need you to solve this and put it right underneath. 1.5 times negative 0.9, and that's negative 1.5. Sorry, 1.35. Okay, now look at this. I have this problem. Look I have these two signs here. So what you can do is you can either put that in the calculator as written, or you can actually just put this guy in brackets, okay? So what we're doing here is negative 4.2 plus negative 1.35. Again, if we were doing this without a calculator, we would look at which number's bigger and do the adding or subtracting. I just want to say something right here too. Whenever you have two negatives back to back, so if I had negative 2 plus negative 3, I always say that it gets more minusy, because if you were on a number line here, this is 0, this is negative 1, negative 2, and negative 3, negative 4, let's go, negative 5, negative 6, okay? Here's the deal. If you're adding negative 2 and you're adding 3 more minuses. You're going backwards, right? So 1, 2, 3. So you get more minusy. That's how I say it, okay? You get some more minusy. So whenever you add 2 minuses together, it gets more minusy, okay? So in this case, you're adding 2 negative numbers together, so it's going to get more minusy. And so that's just a little bit of practice, but if we were to basically do that on our calculator, if we were to do that in our minds, we would get negative 5.85. So it got more minusy, okay? And then this is your answer. So BEDMAS is important, but what's important about BEDMAS is how you do the problem. I want you to show me that you're doing these parts right here first and then writing the answers below, okay? So super important. Awesome. So that looks like it's the end of 2.2. There's going to be some no calculator problems and booklets coming out. You'll have lots of practice on this. So make sure that you get to it.